Now, come on, let's all picture ourselves in one situation. It's gonna be like 8 a.m. in the morning. Your calendar is showing you so many meetings for the day, and the food is getting prepared. And amidst all of this, there is a thought in your mind that says, "Oh my God, I've forgotten to book my tickets for Bangalore." And then you ask your chatbot, like, "Can you book me 2 tickets to Bangalore for Saturday?" And it very confidently, in that agentic robotic voice, goes ahead and says, "Here's the list of available flights." And now you kind of groan because you'll have to manually go through the list of flights and actually like check the prices, the date, and not mess up by booking something at 3 a.m. considering it to be 3 p.m. flights. We tend to do all of it. So much of work from our side, isn't it? Now, let's picture the same situation differently. Instead of asking your chatbot, you end up asking an agent, "Book me 2 tickets to Bangalore for Saturday." And the agent comes up with a very surprising, happy response. Okay? It says like, "I usually prefer the morning flight. And I found one at 2 a.m. And should I also block your return trip? And then remind you to pack your charge this time." Something has finally understood you, right? And it's able to remember that you forgot your charger last time and you had to survive on low battery mode, both really and mentally. Okay. So, what is the difference here? You need not now manually go through the flights, book it, pay, and everything. You have an agent which is like your personal assistant of sorts, which has various tools, memory of what the previous episodes have been, and gets the work done for you, like this. If you get it right. Okay. So it doesn't just chat, right? It doesn't stop with texting you. It actually gets things done for you. As you can see, this chatbot is like a very proactive one. So it basically is like it doesn't actually get things done for you. It is like whatever you ask, it says. But agents goes that one extra mile. It crosses oceans for you to actually get things done for you. And the basic agentic loop, I think most of us will be like aware of it if you're working with it. It is like the think, act, observe, and learn cycle. First, it thinks. So the LLMs, they are that way LLMs, right? So they basically think, what am I supposed to do? What is my goal? And then act. So before acting, you'll of course come with a set of plan that you have to follow in order to achieve your goal. So it acts. And while acting, of course, everything makes mistakes. Agents also make mistakes. So it'll observe, like, okay, this is wrong, that is wrong. It's kind of reinforcement of sorts. It observes and then learns so that next time the same thing happens, it knows as to like how it has to respond. So this is like a very basic introduction of how agents work. I've told this already. So chatbot is just reactive. You ask something, it will be like there'll be a predefined set of instructions given to a chatbot, and based on whatever you ask, it'll respond. As simple as that. But AI agents are not reactive, proactive. So they go that one step further. They use all the tools and reach the end goal. They literally do things for you. So this is the basic difference between a chatbot and an agent. And I think with this, we can get into the topic. Yeah, so there are so many components of an agent. So I thought these are like the preliminary ones that would like help us to get started with building the agents. We can go into it. So we'll relate each thing to human perception so that we are able to like understand it better. So this is like, the sense organs, which will help you to actually understand the environment and respond to the stimuli accordingly. So this part, the outermost layer, as you can see here, is sensory input collection. So it can be from various sources. It can be your database, it can be the outputs from any sensors or anything of that sort. It's basically like input collection, you're getting your inputs. That's the first, the outer circle. The second most circle is data processing and feature extraction. Okay, now you've got your data. What do I do next? This is similar to the ETL process that most of us are like aware of. The extract and you transform it the way you want your system to work, and then you load them however you want. It's like totally up to the objective of whatever you're trying to build. Okay, that's data processing and feature extraction. The next thing is pattern recognition. Now you have the data, you have extracted it, transformed it the way you want it to be. What's next? We need to recognize various patterns from it and like categorize and cluster them into like similar things together. And once you have everything in place, the final step is decision making and response. I have the data, I have the classifications, I've grouped them together. Now, whenever I give it any query, I'm able to make a decision based on whatever I've categorized. Okay. So this is like how perception works in agents. Memory. Just like the human brain juggles between remembering a phone number to one embarrassing incident that happened a few years ago, agents also have, stacks of memory. The first one, short term. So let's say you use ChatGPT or something like that. One conversation, it remembers what you said in the first line, right? You start with hi or something, whatever. Like whatever, then next you ask questions iteratively, it remembers that particular conversation. So the short term is you can keep it like having the memory for one conversation. Like we can have it like the long-term one is like your rules, the basic rules or like the knowledge base that you say, which you want it to persist for every conversation that you want. So those are like the basic ones on which the agents are being built. So that is the long-term memory. Then comes the episodic memory. So episodic memory is like we saw in the previous example that it was able to remember the person forgot the charger actually, right? So that's an episode. So it has its warnings, like the pros and cons for each and every incident. And next time, when you give like a similar incident, it goes to that episode and tries to recall, what should I do better? So that's the episodic memory. The final one, the semantic memory, is like the general knowledge. Whenever you ask it like basic random questions like how are you, or like whenever you feel bored and you want something to talk to you and you go ask, it gives you like the basic general knowledge answers, right? So that is the semantic memory. So this is like a broader overview of what memory in AI agents are. LLM is like the human brain. So it's like a brain to the agent. And there are so many like intricate steps in between, but broadly, it's just these three steps. You give a goal. Any goal you take, it will first break down the tasks. You cannot achieve it like directly. Like any goal that we have, we need to go through a sequence of steps. We first break it down into tasks. There can be tasks, subtasks, whatever, however we want it to. We'll break it down into tasks. And then, even in a Google map, there will be like so many paths, right, to achieve your destination. And based on the traffic or metro construction or bridge construction, whatever, it will suggest you like this is better. Like, and the same path is not better always, right? So you need to weigh paths dynamically. The next step that it does, it weighs the paths. Okay, these are the possible options. What should I take? So it weighs all the paths, chooses one, and let's say even amidst doing everything dynamically, there can still be challenges while like going through that path. It adapts dynamically. That's the last step. So whenever something goes wrong or something, it thinks and it's like, okay, this has gone wrong. I have a plan B. Like we have plan B in our lives, whatever we do. Similarly, we'll adapt dynamically to like whatever problems comes in the future. So this is about basic about the LLM there and tools. So I said that it actually gets things done. How does it get things done? The tools. So these are like the muscles and the bones that we have, which will actually help us to do what we want to do. Like you can have brain, you can think, you can say everything, but something has to help you to do it, right? So those are the tools, and they can be of these types. The data access tools, they help you to access the database or the data warehouse wherever your main data resides. Next comes the communication tools. So this can be like your email, your Slack, your Teams, whatever you want to communicate and however you want to. Then the analytics tools. So let's say you have like some data and you want some patterns out of it, or you want to see like the trend, how it's working and stuff. For that, you can use like the analytics tools. So usage of one or more tools totally depends upon the use case that we have and the problem that we are trying to solve. We can use combination of one or many from these. The next one is like automation tools. So for repetitive processes or something like a reminder, you want like for such things also we can have tools like so that it automates things for you and you not remember to actually get it done by your. The last one is information retrieval tool. So it can be to like retrieve information from any source, from sensor output source or any source you want. It will help you to retrieve data. So these are like basic tools that can like help you to achieve whatever you want. Prompts. I think all of us, at least I have been in a situation when I've not been able to, tell exactly at once what I want, right? And what we do is after going for 20 times, we'll be like, we either be like, please, please, please do it for me, or start yelling at it. You never understand. But when we are not able to say what we want, how do we expect? Even humans don't understand when we are not clear, right? It's after all an agent. We can't expect it to like understand whatever we are thinking in the mind when we are not verbose about it. So to solve it, there are few prompting techniques that we can see in the following slides. I wouldn't say that would solve all the problem altogether, but it might reduce 20 times say the same thing to some poorer. We can try that. These are some of the prompting techniques that we have tried to use in our projects, and I'll be going through them with an example so that it gets better. So zero shot prompting. There is something called in context learning, ICL. So it basically means that in your prompt itself, you can give examples to it to tell it like how to approach a particular problem whenever you give such things. Okay. So zero shot here. Short means example. As the name says, it's like no example. You're not giving example. You're like you figure out. So it's like direct instructions without examples. Based on whatever model it's been trained, right? You'll be getting the output accordingly. As simple as that. This is very similar to the one that we ask ChatGPT. You ask something, whatever it knows, it will say because you did not say how you want it, right? So it's not really good of us to like expect that when you don't give examples. For example, if I say analyze these Instagram engagement numbers and summarize trends, you give some likes, you give some comments, it will be an increase in numbers. You did not say how you want. So I'm saying when these numbers are increasing, so as simple as it is, like increase in the numbers is the trend. So this is like zero shot. Now let's see one shot. One shot is you're giving one example. So one shot is one example. Because you're trying to be like, this is how I want the answer to be. When I ask such questions, I want the answer in this particular way. You can like add this in your prompt itself. So for example, the same thing, you want to analyze the Twitter engagement you're giving and how you want it. Likes rose from 50 to 90, then retweet fluctuated slightly. So you want the output to be in a verbose manner with some explanation like this, okay? If you give it in a prompt and then now ask the LLM, like, now analyze these Instagram numbers and you give some likes and comments, it will understand from an example, okay, the user wants my output in such a fashion. So it will give you like likes increase steadily with a small dip in the third post, while comments showed minor fluctuations. Much better than the previous one which just said increase in likes, right? This is like more verbose and the way that I want it to based on the example. So like if you want to be like, if you're doing a task which is like, which has very similar prompts, we can go with this one shot prompting so that it gets like for this task, I should always do like this. Few short is more than one example. So, like some of the tasks that and the objectives that we try to achieve, right? They might be varied. We might have like different patterns there. So for each pattern, we can give an example. So if you like generalize everything to one example, it might not suffice for all the varieties that you want. If you give like one example for each variety, it understands like, okay, if this is the question, then I have to answer this way. If it is like that, then I have to answer that. So something like that sort. Now, let's say for this, I tried to like give it using the same example. This is a very simple one. This is more useful in cases wherein your patterns are varied. Like in such cases, if you give example for each variety, it really helps. So let's say you give two examples. You want shares increase steadily and comments slightly decrease, and also you want an insight. So if somebody is saying like this, then you should ask questions to encourage comments. So and then the next thing will be like another variety, like impressions rose sharply and engagement related. So if it is like rising sharply midweek, then what should you say as insight? Post during peak hours for better. So like different scenarios. So how do you handle different scenarios? If you try to give example for each scenario, right? And then you ask the same question like, now analyze Instagram numbers, it comes up with Instagram engagement is generally increasing and the insight is maintain a similar content strategy and post timing to sustain growth. So basically like you're guiding the response based on the way you want through your examples. So if you have like even complex problems with like lot of variety in your inputs, you can like optimize it by giving one example for each so that you get a better response. So this response is comparatively better than the one that we started with zero shot, right? Totally. So this is about the short prompting. Chain of thought. I think whoever is like has worked with LLMs will be like very familiar with this chain of thought prompting. It's like a very widely used pattern. So step by step is like right from our school days If we give the final answer, we don't get marks, right? How did you derive the answer is the question that we've always got. And we all know that agent LLMs hallucinate. And if you ask like a very difficult mathematical problem and it gives the answer, our human brain overthinks and we'll be like, how did it? Is it hallucinating or is it the right answer? So you want the chain of thought. The chain of thought is like, tell me how you arrived at this answer. It is like encouraging it to tell you like a step-by-step reasoning to get this done. For example, you can like give an example to say that how it has to think and how it has to give your answer. So let's say John has 10 apples and he gives away 4 and then receives 5 more. How many apples does he have? Normal addition subtraction problem. But how you want it to give answer is he starts with 10 apples, he gives away 4, so now 10 minus 4, do it first, and then he receives 5 more, so it's like 6 plus 5. So basically like you are encouraging the step by step reasoning, like trying to control the way it thinks and gives you the output. So, and now if you ask a question like if some speed distance time problem, like if a train travels 60 kilometer per hour for 2 hours and then 90 kilometer per hour for 1 hour, how far does it go? So it does the step by step based on how you want it to think. So the first part is like 120 kilometer, second part is 90, and the total distance is like summing up and then 210. Now, if you see this response, you'll be like, okay, it has gone. You'll go through the steps and you get more confidence. So this is usually used in like reasoning tasks or like very complex problems where you actually want to understand how the LLM has arrived at a particular answer. The hierarchical prompting. So this is like you are breaking the hierarchy. The word is itself saying it. So you are breaking down the task. There might be a big task or goal that you want to achieve, but how are you achieving it? You are breaking down into subtasks and you're asking your LLM to reply accordingly. So for example, you want a meeting summary. You post just the recording and you will like, give me a meeting summary. It will give you a decent one. It will give the way it wants to. But let's say you want with like meeting purpose, then you want the date, then you want agenda, then you want action items. So you have a clear picture in your mind as to how you want the output to be, right? So you can actually break down the tasks. Wait, hold on. Start with the meeting purpose. Then go to the date, time, and participants. Then capture the agenda, then the important decisions, then the action items, then the next steps. So if you give the tasks, the breakdown of the tasks, and you yourself provide a sequence to it, the output will be like under each topic nicely, we'll get the output the way we want. So hierarchical prompting is basically like us trying to control and break the big task into smaller subtasks and give it in the prompt. So I think with this, we are done with the components of agent. Are we good till now? Yes. Cool.
One question.
Yeah.
In terms of episodic memory, which we talked about, is episodic memory is a part of your long-term memory?
Can be or cannot be.
So in terms of line graph component, when I'm creating an agent, how does I create an episodic memory? So I'm aware of short-term, long-term, but how do you create in terms of framework? And how
Okay, I'm not sure about Landgraf specific things.
any sort of framework.
So like in Google ADK, it actually like helps you, makes you to configure like such stuffs. Like you can like name it and you can also define like how you want the memory to be. And you can store it accordingly.
So then ADK will automatically derive that for this particular prompt.
Yes.
This information.
Yes.
So then it will take it without developer.
Without developer telling. Yeah.
Yeah, you think this in workflows. So agent workflow different and agentic AI workflow different or both?
We'll be seeing it.
Okay.
Okay, so any other questions? We'll take it in the end. I think we are running out of time as well. So yeah, so we'll see workflow patterns and agentic patterns. I think the slide is like pretty clear of what, I don't know if it is seen, it's fine. Yeah, so workflow patterns are like predefined paths. Like you don't want it to think and all. You're like, do this. If this happens, do that. I am controlling you. You don't think, you don't do anything. Whatever I said, do it. Get it done for. That is like pretty much predefined paths. You say, you define the path, go this way, you will be good. That's workflow patterns. Agenting patterns is dynamic decisions. You give it the tool, you give it all the required data, everything you give it, and you will like Now you think and decide what you want to do. You just give that autonomy to the agent to decide the path it has to take, the tools that it has to use, how it has to achieve your goal. So that is agentic patterns. So we'll go through like some of the workflow patterns and agentic patterns in the following slides. We'll start with the workflow patterns. Prompt chaining. I think this is like a very simple one. It's like a series of steps. So chaining is like one after the other. So there'll be a first task. The output of that task will be your input to the second task. As simple as it is. So it's like a breakdown of task into series of steps. You go one step at a time, and your first step's output will be fed as an input to your second step. So on till you reach your end. So here it's like if you want validation over each step and transparency over each step for such pipeline style agents, like if you want like proper validation and control over each step, you can like use this prompt chaining technique. Okay, it is better than example, I think. Let's say you want to like summarize some information. So how you want to summarize? Not directly. First, you have to extract. A big news is given, you want to extract. Then transform the way you want. Then that output will be given for the summarizer part. So for example, let's say the company made 5 million in revenue and spent 3 million last quarter. This is the news. So you want to summarize it and just want the insights, not the other pieces. First thing, extraction. So what is the main thing here? The revenue is 5 million, expense is 3 million. And you're transforming it. Instead of like two numbers together, what am I interested in? Profit. Tell me the profit or loss. So it's like, profit is 2 million. And instead of just saying profit 2 million, you want to be more verbose for your customers or the end user, let's say. So it'll be like the company earned 2 million profit last quarter. So some input like which has revenue and whatever is spent is being transformed to the company earned 2 million profit last quarter by like chaining the output of one step to the other. So this is like a very simple example. So the example will be like quite simple for us to like understand, and we can like use it based on our use case and what we want to achieve. Next is routing. I think this is also something that's like very familiar. So it's like, so when you have like so many categories, you can like handle one route separately. So it's like you want to do one job, then just go with that route. No need to like, it's like if else. We can have it like if else. So if some condition, just go to that route. Don't bother to see the other routes. Then if it is not that, and if it's the second condition, just go that route. Don't be oblivious about the other routes. Okay. So again, an example would be, so customer service, right? So if it is like a general query, just do that, execute that function. Something related to payment, execute that function. So if it is related to payment, then you need not go through the loop of general query or something, right? You know the intent. So the LLM will like identify the intent and directly route it to that particular path. And it will be like oblivious about the other stuff. Simple if else loop is what I could like try to relate to. And then if it is about refund request, go that way. And if it is something for technical support and has back and forth conversations, just take that. So this is like, as the name suggests, it's like routing to that particular path alone. Next is parallelization. So always like when tasks can be done in parallel, you can very well do it, right? Why do you want to wait for sequentially processing it when they are like totally independent of each other? It will actually help us to like improve the speed at which we are delivering as well, right? So you have a big task. If you can parallelize it, this is like we cannot try to have like a sequential task in parallel and try to handle all that. If the tasks are really parallelizable, we can go with this approach. So you can have like a different subtasks, and then this will definitely increase your time. Reduce your time as well. So for example, you want to check whether a piece of content is inappropriate or not. So these are the three things that you should do. You should analyze the tone, check for hate speech, and any explicit content. This need not be done sequentially because they are like different meanings, right? You can just pass the content directly. The first function will like analyze the tone. Okay, how is the tone? Is he being rude or offensive or something like that? Then you'll check for hate speech based on whatever words I've given. So all these can happen in parallel. And then like check for some explicit content, whatever you don't want it to. And everything can be done in parallel with the input that you provide. And finally, there will be like an aggregator. So this aggregator will receive outputs from all of these individual functions. And it will be like, okay, so this is there, this is there, this is there. it will try to like synthesize one final output based on all the outputs from the individual functions. And then you get your final output. So this is like for like how you do parallelization. That's like the basic workflow patterns. And now we can go with the agentic patterns. The first one is like the reflection pattern. So this is similar to having LLM as a judge. So the whenever we get any output from the LLM, of course we need human in the loop and we review it, right? Sometimes you can make the LLM itself be a critic and try to check the output whatever it has generated. So how this basically works is you give a query. Okay, the LLM will generate some initial output, and this LLM reflect LLM will act as a critic. So it'll be like, this is wrong, go change it. Like when we do our projects, we'll always be sent back where this change that until it is satisfied. So who defines the rules of what the critic should do? We. So it works as good as you ask it to. If you like give detailed instructions for the critic, like check for this, check for that. For example, this can be used for checking your code. So LLM, we are using LLM to generate code, and all of us will be following like the solid principles, object calisthenics, whatever principles that we follow within our team. In the critic, if you add whatever code is being generated should follow all these rules, and of course all the unit tests and integration tests has to pass. If you like add all these rules in your critic, it will validate the initial output whether all the rules have been followed, and then it will ask the LLM to like iterate, no, go fix and come. It will again come with the output. So this goes in an iteration until the critic is satisfied. Now when will the critic be satisfied? That is also defined by us. If we directly be like, check for the code quality, it should be good. What does that mean? So it will understand whatever it wants to. What is a good code is something that we should specify. So how well this works, this agentic pattern works, totally depends upon the way we write the prompt. You have to like how well the human will like critically examine the code. Same instructions we have to give it to this reflect critic LLM as well, so that it does the job better. Yeah. So similar example, let's say you ask it to like, please write code for some task. The critic will be like, there's a bug on line 5, fix it. Or you can like ask your critic to actually run tests, right? And it is like failing the unit test 3, go change it. So as I said, I'm trying to reiterate again, how well the critic performs depends on how well we prompt it to. The better we do, the better results we get. So that's about reflection pattern. Next is react pattern. So from the name, it is like re and act. Re stands for reasoning, act stands for action. Okay. So it is like pretty much from the name. It basically, as you can see from the slide, it empowers the LLMs to think and act iteratively. So what does that mean? You give a task, okay, to the LLM. LLM will think, okay, this is the goal that I want to reach. And how do I reach? I come up with a set of steps and the path. And I've been like reiterating on the fact that it has a lot of tools, right, for actually getting the things done for us. It will go through, search through the list of tools. To achieve the first step, what tool should I choose? It will have the tool descriptions. So what are tool descriptions? For each tool, there will be a purpose, right? You cannot use a search tool for calculation or vice versa. So it's like each tool will have a tool description, and your LLM, the main agent, will be aware of each tool along with its description. So once it has come up with a set of tasks, for the first step, what tool should I call? It will think, and based on the tool description, it will decide. And once it has decided, it will act. So let's say it's something that's related to like a booking a flight that we saw in the example earlier. So like go to make my trip. So let's say we're connecting to the make my trip website and there is a tool for it. We'll see how to do it in the later part of this presentation, but let's say that's what we want to achieve. And then acting on the environment, like actually going to make my trip and booking is the action on the environment. And let's say it's throwing you an internet server error or some error. It'll come back and it'll come back like this. And the LLM will be like, okay, it has failed. Should I retry? If it is like some network issue or network lag or something, I can retry. So it again thinks and it acts. It will be like, call the tool again. So such decisions. So we saw, right? It takes dynamic decisions if something goes wrong. And it's since we have given it the power to think, it'll again retry. And then now if everything is positive, it'll like resend, okay, I've got the tickets are booked. The final response is like, I've booked 2 tickets for you. We can understand it with an example, and yeah, as the slide says, it gives you a brain to think, the first part, and the hands to act, the tools. Okay, so you are asking a question like, I'm in London, do I need an umbrella today? It can be London or Bangalore or what. It goes to the LLM. And the LLM has the list of tools, right? Let's say the calculator, the coding tool, and some weather API as well. It will select the tool. Okay, what tool it will select? It will select the tool to invoke the weather API. That's the environment. It will act on it. And it will get a result from it. Let's say there is some error, retry. Again, go select the tool weather API, again invoke it. You'll get the weather. No, it's all good. You don't get a 500, you get a 200. You're getting your output. Weather report will be there. LLM will reason. It will reason. What did the user ask? The user asked, do I need an umbrella? Did I get an answer for it? So it has the power to think. Now my objective is achieved. So I'll be like, yes, you should carry an umbrella. It's likely to rain today. So this is how React agent works. And this, how many times it will retry, who will control it? We will control. So as I said, how well it works depends on how well we write the prompt for each and every step. So if you are like, do not retry more than twice, it won't do. If you leave it to it, it will keep retrying again and again until it's tired, and all our time will increase, response time, latency, all such problems occur. Orchestrated workers. I think this is one thing that is being used in like many agentic projects as well. So as the name suggests, you have an orchestrator and the other agents are workers. So it's like a multi-agentic system. Okay. So orchestrator, like music orchestration, something like we can relate to anything of that sort. What is orchestration? You have an idea. Okay, this is, I want to achieve this. These are the tasks. And the orchestrator will also know like what all agents are there and what each agent does. So it will be like, these are the tasks. This agent is specialized in task 1. I'm giving it to you. Second agent is specialized in task 2. It will basically orchestrate and like, you do this, you do that. Just assigning tasks to it. Okay, so there will be a central orchestrator which will plan, decompose, and delegate, basically delegation. So it will have knowledge of what each agent does in that agentic system, and it will like whatever each agent specializes, right? If you get a task related to it, orchestrator will basically delegate it to that agent. So it's better with an example. Let's say we want to plan a trip to Bangalore or any place of your choice. The orchestrator will be like, okay, that is my final goal. What all should I do to plan a trip? It can be like, find the stay, then some fun activities that you want to do. Of course, for food, you need restaurants. And then how will I go there? Travel. So these are like 4 main things. So this is like an example. You can add how much ever you want. And let's say the 4 agents that are there in that agentic system are accommodation agent, activities agent, dining, and the transportation. So each task will be assigned to that particular agent. So as you can see from the slide, so accommodation agent. So to the accommodation agent, what the orchestrator will say is, you find stay in Bangalore. It will not be like you keep in mind the dining agent restaurant. No. What is the purpose of accommodation agent? Find stay. So it's like specialized and expert. So we would, some of us would have used persona based prompting. Okay, so it's like it's specialized in that particular thing. So the orchestrator will give only that, and whatever doubts the accommodation agent has, it will communicate to orchestrate. Okay, so here something failed. I want more clarifications on this. So whatever, it communicates with the orchestrator, and these agents, they don't talk to each other. You can actually make it talk if you want to, but in like the general orchestrator worker pattern, it's usually like the orchestrator and the sub-agents, they communicate alone. And then each agent will do its job in isolation. They'll get it done. They'll have their output, and there will be like a synthesizer. So you don't want your final itinerary to be like one line, one thing, right? You want it to like proper agenda. Like this is the hotel. This is your transport. These are like good restaurants, and these are like some places that you must visit. So the synthesizer will basically combine all the results, and how you want to present it, it totally depends upon how you write the synthesizer. So if you want it like in a very fancy way, you can give your choice. Otherwise, if you just be like combine results from all the agents, it will combine in a messier way that we can't understand. So if you are like very clear on how you want the final agenda to be, it will like basically do the way you prompt it to be, and you'll get the final nice itinerary. Okay, and you'll be satisfied. So that's basically how the orchestrated workers work. That's also one of the multi-agentic pattern, but we have like two major multi-agentic patterns, which are like supervisor approach and swarm approach. We'll see that a bit later. What is a supervisor approach? So supervisor, the name says everything. So it's like hierarchy is there, some supervision is there, like there is separation of concerns on what each thing is doing. So let's take a typical project management problem. PM agent is project manager agent. I'm sorry for the short form. But let's say you give a query. The project manager agent will try to, be like, talk, understand the business objective behind it, why we are doing it, and what all tasks has to be achieved and everything. And let's say we have a tech lead person, so the project management agent will like break down the business use cases and when the sprint should start, when the sprint should end, what milestones should be achieved after each sprint. All that the project manager agent will plan. It will then give it to the tech lead agent. So now the project manager agent will not talk to the devs and all, the dev agent. It will just talk to the tech lead agent and be like, for this business use case, get the tech done for me. These are the deadlines and everything. Now, there is a separation of concerns here. This tech lead agent will actually manage the SDE and the DevOps. So, like what infra issues are there and how you have to code. So, this tech lead agent will be delegating and communicating between the DevOps agent and your SDE agent. So, there is a clear separation of concern. Like PM agent supervises the tech lead, the tech lead supervises your DevOps and your SDE. The tech lead can ask the SDE to like actually, give some data to the DevOps, but it is all managed at the bottom layer. It is all managed by the tech lead agent. So let's say they go on iterations and the tech lead, once that it is satisfied, it goes back to project manager agent. And now let's say the project manager agent is like dissatisfied or something, it will again go to the tech lead agent and not directly to the SD agent. So basically, what I'm trying to say is that the supervisor approach lays down clear hierarchy and there is a proper separation of concern on who has to do what. And they don't interchange their roles or something. It's like clear, defined who has to do what. Swarm approach is like totally opposite. You don't have a supervisor. Every agent knows what the other agent is doing and what it is specialized in. So I think it will be better with an example. The user is requesting for task one, let's say, and agent one is the one which is like specialized. It will be like, okay, it will propose a solution. You go back and forth, have conversations, and once it is confirmed, right? The user confirms, agent will be like, okay, the task one is complete. Good, all good. Now the user will like again ask for some task two. Agent one, knowing that, okay, I'm not capable of doing it, but I know another agent who can do this task well. So what this agent will basically do is hand off, or like it clearly knows agent two will do this task. So it'll actually delegate or hand off. Delegate won't be the right word because it is not supervising. Everything acts like friends here in a one group. So it's like a teamwork. So it'll be like my team member knows it better. Okay, I am handing off this to the agent 2. So it uses the handoff tool or logic. The agent 1 hands it off to the agent 2. And then the agent 2 will then carry it forward. So once the task is being hand off, so the agent 2 will propose a solution. Then you can have back and forth conversations with the user and like get the task to complete it. So this is like two agents, but you can have like 3, 4, 5, 6 agents, and each agent will be aware of what the other agent is doing, what it is specialized in, and how it works. And based on whatever task you're getting and which agent is specialized in it, the handoff tool or logic will happen within them. I think with that, we end the workflow patterns and agentic patterns. A quick recap. We saw chatbot versus agent, what is what, and then how an agent basically works, the basic 5 components, and also about the prompting techniques, and then some workflow patterns and agentic patterns. So I'll take a pause here. So I mentioned something that the agents connects to tools and gets things done. Is it very easy to connect to make my trip and just pay? How does it happen? So that will be the second half of the talk. So thank you, folks. check. Am I audible? Yes. Okay, cool. So next, what we're gonna see is one of the most hyped words you would have ever heard, MCP. So it's very hard for us to be in the tech industry and not hear the word MCP so far, I guess. It's been really hyped, but let's just see why the hype and understand what actually happens, right? So MCP stands for Model Context Protocol, and basically what this enables is communication between an agent and its tools, right? So everything that you see on the left-hand side of the screen, Cloud Desktop, Cloud Code, or other applications, right? These are all AI applications that want to communicate to sources of data. Now, why do they have to communicate? It's very simple. The things on the right-hand side are basically your sources for context, right? Now they can take actions. For example, Shweta had mentioned that you want to book a flight. Here, what is your source of data? Whatever flight information, right? And you can get that from a database or by using an API or whatever. So basically, MCP is something that connects your left-hand side, your AI application, to the resources that it requires, such as data or an API that will provide the data. Now, this can be from the data that you're connecting to can be from anywhere. So if you're using Google Maps MCP server, you would have map data. And then Slack gives you anything related to your Slack workspace, right? So that's basically what MCP does. Now, if there were no MCP, what are the problems that we would face, right? So there was AI agents without MCP also. But then the problem they faced was that every single different provider, right? Here in this case, it's Anthropic, Google, and OpenAI. They would have their own way of integrating with tools, which means we have to bother with the burden of understanding how each provider will want to connect to a specific tool. So what MCP does is it is giving us one standardized way that, okay, as long as you're following MCP, you don't need to worry about who is maintaining it or who has created this particular AI application, right? Now, if you've been following something on like MCP, you would know that it's called as the USB-C for AI tools, right? Is one of the very commonly used examples. So what we're trying to do when we say MCP is it's a client server architecture. So basically we have a client and a server. The server is used to expose the tools that we want, right? So if you're using a Slack, then you would have tools that will enable you to read the Slack data, write to Slack, whatever. And on the left-hand side, you have an MCP host. So what does an MCP host do? It's basically a combination where you have an LLM embedded, plus it has something called as an MCP client. This client is responsible for communicating with your server. It is a normal client-server communication. The only difference is that it's made for AI agents, which means your LLM will be able to access this information that your client fetches for you, right? And now, coming to the integration part, right? You don't need to really worry about what is the LLM that is behind all of this. A very good example for this is using tools like GitHub Copilot. How many of you have idea about it or have used it? Good number of people. So there you have agent mode, and when you're in agent mode, you really don't worry about what LLM you're using, right? Your Copilot is built for you to switch between LLMs, and still, if you've connected with MCP, you would know that you really need not worry. You can change the LLMs and still talk very easily. That is the problem which MCP solves for you. Now, how do we usually use an MCP server, right? It's a very simple process. And what you would do is normally you would require a config file, something like this. Here I have mentioned if you can see under the servers, you have the names of the servers. The first one I'm using here is the Atlassian MCP server. So this one is used for communicating with Atlassian products like Jira, Confluence, etc. You can try it out if you're using those products. It's a really good way. And the second one is an MCP server, which I wrote in the local. But what I'm trying to say here is that you can have two types of MCP servers, ones that run in the local and ones that run in remote. And based on that, you can have a configuration we're giving the URL and also the type of transport that you want. Okay. So now let's see what actually happens when you're using an MCP server. What happens when you're actually connecting, right? So let's take an example where we're like, okay, we have an MCP server for a calculator, right? What does the calculator do? It has 4 operations: add, subtract, multiply, and divide. So
This is like a very toned down example just for understanding. But the idea is that your MCP client will ask the server, what are the tools that you have? List the tools for me so that I can get an understanding, right? And what happens is your server will return a response. Now, this is not the exact response. Of course, it's boiled down to make it more easy to understand. But the point is, you'll get data that will help you understand what the tool is actually doing here. Now, when you take the add tool, you can see that it has a description. And the description says this tool is used to add two numbers and it takes input A and B where both are numbers, right? So when you're calling the add tool, your client is basically knowing this is all I need to know for calling the add tool, and this is the response that I will get. Now, this will happen for all the other tools as well. This process is called discovery. Okay, so far so good. The next thing is called invocation. This is where you're actually calling the tool, right? So once your client is aware that, okay, these are the tools that I have, and your user is like, okay, I want to find the sum of two numbers, your client is like, okay, we have a tool that we can use, which the MCP server has, and this will get me the sum of two numbers. So what we do is we'll make the tool call, and then we get the result. So this is invocation. Yeah, sure.
In this whole flow, I see MCP client is the only way which will talk with MCP server.
Yes.
Is there any way through which LLM can directly talk with MCP server? That is not possible.
No, so for MCP, you need a client and then you need a server that is established. But your LLM essentially communicates with your MCP client. You don't see that because when you're using something like Copilot, it abstracts out the MCP client portion for you. So it looks like the LLM is talking directly, but essentially you would need a client there.
And if I open, say, two terminals in a VS Code or two ChatGPT instance, does it mean I have a two MCP client now running on my machine? If I open two prompts, prompt window, right? Does it mean two MCP client or does it still mean the same one MCP client?
I'm not really sure about that because it's like underlying implementation of how it works. But if you're building it, I think it could be at the same MCP client. Maybe.
Host is same.
Host is same.
Host
yeah,
is
yeah,
same.
exactly.
Like every prompt is a new MCP client.
No, that's not. Yeah. Okay. So can we move forward then to the next? Okay. Now, I'll like to give a real life example where I had actually used MCP and how it helped me. So we were using a couple of Atlassian projects for our development lifecycle and all. So what we used was Jira and Confluence, and we were using GitLab as well. So the idea that I had in my mind is whenever I wanted context about certain services or repositories which I was unfamiliar with, and I wanted to speed up something there, what I would do is maybe we can use our Copilot or Claude, something like that, to speed up this process. What are we essentially doing here? We have an Atlassian MCP server. This MCP server can pull details from Jira and Confluence. Now, what does that mean for me? It means that I can get the details of a specific ticket, right? Now, I can say I want the details of story 1, 2, 3 or something. I can get all the details that are listed in that story, which means the acceptance criteria, the test cases that have to be there, all of that. And if there's any relevant documentation that's there in Confluence, that's even more of a bonus point because all of that is context for me to understand about that service, which is unfamiliar to me, right? So the next thing is using an MCP server for GitLab. So now what do we get from GitLab? We can get the actual code, right? So consider the use case where you want to review PRs or MRs, right? If you're using an MCP server that can pull the diff that you have, like what has changed essentially after you've raised that MR, you have the code, you have the ticket, and you have the documentation essentially, everything in one place. Now, what does this help with? It helps with understanding that, okay, this is why you have raised this MR, and then whatever context you need beforehand, you'll have a much better understanding than randomly just going and looking at the code files, right? So you can also use tools like Copilot and all to get a better context of how the service is, or when you want to groom something, a new story or something, you can use it for that as well. So this is one use case which I felt it's useful. There are a couple of MCP servers out there for various tools, so you should just go and check it out. So Slack has one, and then recently Zomato has one. I actually saw a video where someone was trying to optimize the ratings and also get a really good biryani from Zomato. So from a restaurant which they have not been to earlier. So the point is, it is trying to ease out things. Whether or not that's something we want to do, it's a different question, but it can do it now. So now, are we good with MCP? Can we move to the next thing? So this is also another protocol called A2A. Now, A2A is basically agent to agent. And I want you to understand like A2A, like, so I'll give an example here. Assume that we have all these agents, right? How many do we have here? 5. Now, you have an assistant to whom you will talk, and you're asking the assistant, I want to plan a trip or something, right? And here you have 4 other agents. Imagine each of these agents was maintained by different companies, right? So for flight booking, let us assume it's Indigo. Indigo is the maintainer, and the agent is something that is developed. You don't know the framework, you don't know how they built it, who is maintaining it, nothing, you know. You just know that Indigo has your agent and I have to use that. For hotel reservations, maybe something like Airbnb. And similarly, now the main concern here is that this is deployed somewhere else. None of these agents are in the same place for you to do communication easily. So in that scenario, A2A helps you in a sense that it makes it framework agnostic. It makes it agnostic of all the details that are related to integration or how you want to maintain it, who is maintaining it, do I have to worry about anything on that sense? No. As long as I follow A2A, I can ensure that one agent can talk to another agent. That is what A2A does for you. So what problems are we solving here? Again, the same thing. You don't have to worry about any integration related specific to the framework. And earlier, before A2A was there, we were following the process of making agents as tools. So in the earlier example, you would have an agent called AI Assistant. The flight agent would be the tool for that agent to use. But I think the people who developed this protocol felt that by exposing an agent as a tool, you're limiting its capabilities, because by nature, a tool is something which does a deterministic set of things and you're using it to help the agent. And 2 agents cannot be just like an agent and a tool. It's very much more advanced than that. So the third thing is to handle scalability issues. So now we had in the earlier example like 4 agents. What if this was 40, right? We would need one way of talking to all these agents and it should be in a coherent way. That is why we need A2A here. Now, let's just go through a basic life cycle, like what happens when you use A2A. But before that, there are some specific concepts which you should know to understand better. So the first thing is an agent card, right? I think every one of us here is familiar with a business card, right? What does a business card do? It basically lets you know information that who am I and what do I do? How can you contact me? And the main purpose is for someone to know about you, right? The agent card is the agent's business card. If you notice the JSON snippet on the left, it says that you're describing the name, the description, and there's a section called skills here. This is basically everything that you can do with this agent, right? And in the last, there's an endpoint. Now, the actual agent card will be much more detailed than this. That's still there. But basically, this is telling you how to contact that agent and what that agent can do.
Is every skill is actually a tool under the...
Could be. It depends on how you've written the agent.
Oh, you mean one tool can have multiple skills defined in this file? Same tool.
So essentially, you would want to keep a tool to do one kind of work, right? So it is better if you do it that way. You can try having a single tool to do more than 2 things, but whether you would want to do that is subjective. It depends on the use case. So the next thing is task. So task is basically a unit of work, right? Whenever 2 agents are communicating, it is a piece of work. And what does a task contain? It contains things like your name, description, what is the expected output schema, and how do I send information to this agent and all. Why do you need this is very simple. Now, let us take the example which we started with, right? You want to book a flight. Now, is it enough if I just say I want to book a flight? No, right? We need a lot of information. If a user gives such a blunt example, like I want to book a flight, the agent should be the one to ask, what kind of flight you want, when do you want to book that flight, from where. All of this will happen in a long running conversation. It's not something that's like just a single request and response. So for that, you need a long running conversation where each unit is a task there. That's where task fits here. The next thing is a message. A message is a communication between an agent, right? So here, usually you use the term called client agent and remote agent. The client agent is the one who's making the call to communicate. So in our example, the AI assistant was the client agent. Flight agent is the remote agent. So message is how those two talk to each other, right? Now, why do you need messages? You need it to give instructions or some kind of context that is relevant to either of the agent. Okay. The next thing is artifact. Now we have two agents. These agents are talking on and on. And what is the end result that you expect, right? You need some output. This output is called as an artifact. It can be an image, it can be a document, it can also be some kind of report or code, anything it can be. But the core concept is that it's an output that you received after this communication. And it's basically the agent's work. Now that we have seen these four concepts, let's just see where they fit in the life cycle, right? So the first thing is when there are any two agents and your client agent wants to make a call, the first thing that happens here as well, like MCP, is discovery, right? And then here the flight agent tells you that, okay, here is my agent card. This is what I can do. And then happens the process of connection and authentication, post which they start exchanging messages. So it's something like, I want to book a flight to Bangalore, right? And then the flight agent replies with, sure, here are the flights. And then the next process continues like that until the flight agent finally understands that, okay, this is the flight that the user is looking for, and it sends the information. That is why you get the artifact, right? So this is basically how life cycle looks. This is with one agent. Now, if you have n number of agents, this process will happen across all of those agents, right? Now, I think we're done with gateway as well. So before we step into the next section, a quick check. Are we good so far? Like, can we continue? Okay, so this is my favorite part of the talk because, sorry? Please go ahead.
So, you mentioned that you can also what are different frameworks move into it.
Yes.
Explain that.
So it's something like, let us assume that my flight agent is there,
Yeah.
right? I might use LangGraph to build that agent. And suppose my hotel agent is something that I've developed using ADK. I need not worry about how do I connect these two agents, because as long as A2A is being used, everything is the same to me. There's a client agent and there's a remote agent. I don't have to worry about which framework I'm using to build that agent or to communicate.
It's the endpoint part.
Yeah.
Define like where it will present. So that will be different for these two different.
Yes, that's it. Cool. So yeah, now whenever, like, since all of this came up, we've been told that, okay, we should try using MCP, we should try using A2A, please build with agents and, like, check it out, all that. So I think there's also a part that we have to consider, which we don't really think much about. So the question is, do all problems really need agents and MCP, right? Now, I started the presentation with a calculator example. I can very well build an MCP server for a calculator, right? I can still use it. I can run it in local and use the MCP server, make an LLM call and do that. But do I really need to do that is the question here. This is a very exaggerated example, but there are cases where we are force fitting all of this without seeing proper value in it. So along with knowing when to use this, we have to know when it is maybe not really adding value to that. That's when we can properly find the exact solution, right? So I don't need a multi-agentic system and MCP just for doing something very trivial. That's the point I'm trying to make. So let's do a quick exercise kind of thing, right? Suppose you have these three tasks. One of this is a straightforward thing, and one of this actually is a task where agents add value to it, and one of it is something like your life will be easier if you use an LLM for it, but sure, you don't need an agent for it, right? So out of that, can we categorize which one falls in which bucket? Right? Anyone wants to take a try? Yeah. Okay. And
I think LLM is
yes.
starting at CSS or Python command.
Yes, it's a Python command. So I think he's said it correctly. When you sort a CSV file, right, and each of this is like based on my personal experience. So I'll assure you that you really need to consider this. But the point is, I was actually giving a query where I was like, I have a CSV file, I have some rows in it, I want to filter the rows, and when I'm returning the user the response, I want it to be sorted. Naturally, since I was using agents, my first thought was, okay, the prompt was something like filter the rows based on this, and then sort it, right? Now it was doing a good job, but sometimes it was not sorting it properly. For a while, I was trying to do it again and again, and then I'm like, why do this when I can use a dot sort function, right? How much, whatever answer I get, how many times ever I sort it, it's gonna stay the same. It's not something that will change. It's not something that's dealing with the uncertainty part of it. So I was like, you can directly use a dot sort and just get over with it, which really helped there. The second case is summarizing an article. Now, this can be specific, right? There are some use cases where you have super domain specific information where having an agent makes sense. But if you're generally doing something, ChatGPT does a very good job of summarizing. Gemini does it for you. And there it makes sense. Like some use cases, LLM add value, but do you need an agent for this? Is something you need to think about. Third one, book me 2 tickets to Bangalore this Saturday. Here, you're actually doing a lot of reasoning, right? Because the 2 tickets part is not sufficient to complete this operation. You need to think, okay, for whom, how many people, what are the details, all of that. So there, actually having an agent makes sense because it's handling some actual reasoning and logic there, right? So that's essentially what I was trying to say. When the task is certain, you don't need an agent there, right? And if you don't see value in proper decision making or the use case does not need it a lot, then you don't need an agent there as well. So, and the reasoning part, of course, right? The next thing. So these are the considerations when you're using MCP, right? Everyone has told us to use MCP, but there is a problem with it, right? If you've been following MCP a lot, you will see that there are two statements that are famous about it. One is that it's USB-C, and the second one is this. The S in MCP stands for security. You all know there's no S, but the point is, since like people realize that you can have MCP servers, a lot of them have been coming out, right? And everyone's building MCP servers. Now, the thing is, a lot of people have been using these MCP servers as well. And there are some malicious MCP servers, which when used can actually lead to like cyber security attacks kind of thing. So one particular thing which I recently read about is called the tool poisoning. So we saw that every tool has a description, right? Now here what basically they try to do is make the description very convincing that it's a legit task and it's a very valid thing. But what it does inside the function can be something entirely different. So these kind of attacks are very common because every time attackers try to attack something that's very new and people are using it a lot, if you have not had enough security and like patches done, they try to attack that. That is MCP right now. So please use proper MCP servers that are like from official sources. Don't try out random MCP servers. If you want something and it's not been built yet, you try building it yourself, and then you can have the belief in it. Yeah. So when should you use MCP, right? Where does MCP actually add value here? If you're connecting to multiple systems. So in the initial use case, right, we were seeing there was an example for a trip planner, right? There, for example, if you need information from multiple sources, which is the case there, using an MCP server makes sense there. But sometimes, for example, let us assume that there is a weather API, right? If you call that API, it will give you a weather response. Now, you know that you're going to call the same API again and again. You might have to think, do I really need an MCP server there or do I need something there? Because it's just one API call. You can do it, you can get the information and use it, right? So if you don't need integration and you don't have a use case where you have a lot of tools and you want to figure out where's the right tool, it's very certain, then it makes sense to use not use an MCP there. Unless and until you have a lot of figuring out an uncertainty, try not to use an MCP, right? So if you know something which you'll exactly call, like the weather API case, and also there's no reuse or some kind of integration issues that you want to worry about, then you need not use it. Now, this is another checkpoint before you move to the next part. All good? Any questions so far? Okay. Cool. So I think this section is about our learnings which we had while we are building with agents. And it's something which will help you sustain in a longer term when you're building with agents, because you would want your agentic system to work fine even when you're adding new things and removing new things. And it's dealing with a lot of uncertainty. So these are the steps that can help you ensure that you're doing things in a proper way. And the first thing is to build one agent at a time, right? So what I mean by that is something similar to, like doing one thing at a time. So the point is, let us imagine this use case, right? If you notice this properly, this is the orchestrator worker pattern which Swetha was talking about. So the idea is that the user will ask for planning a trip. The user wants flight tickets and hotel stay. So he'll give all the information that he wants to be specific about. And the flight agent and the hotel agent are responsible for doing that specific tasks there. Okay. So if you see in this example, the user has said, I want morning flight. So yeah, that detail has been passed to the flight agent. And same thing for the hotel. And in the end, we have another agent called the notification agent, which is supposed to give the user the final response. So now, if you were to build this system, where would you start? What is the first piece that you would pick up?
Agents.
You're saying the blue ones? Yeah. Any specific reason why?
First thing, do my logic first with the flight rate. That is before hotel.
Okay.
That is sequence. User sequence.
User sequence of things. That's actually a pattern where you have things in sequence. So while putting them together, you might want to do in a sequential way. So here also, I think you both had very valid points. That is actually something which needs to go into thinking, because imagine I build the orchestrator first. How will I test the orchestrator? I have nothing, right? So we should start with something which can be tested individually. Here, the flight agent is that component for me. I can just hit it with queries like book me a flight on this date at this time. And when I know that it's performing good enough, I can then plug it into the orchestrator anytime, any point of time I want. But the thing is, tomorrow when something goes wrong, I should be able to figure out which one of these made the mistake. That is the key thing here, right? So same goes for hotel agent. So ideally, if you're working in a team, you'll have many people pick up each individual agents first, get them done, and once you know that they're performing good, then plug it into the orchestrator, right? That's what build one agent at a time meant. And the next thing is logging. So one of the things which you might think is that, okay, agents are intelligent enough, so do we still need logs, right? The point is we very much need logs here, because normally when we log, it is for cases where we know that everything is deterministic. Here, we don't even know that. So you can ask the agent one thing at a time and it may give you a different response the second time. So you really need logs here, and I'll explain why here. So imagine the same scenario, right? But this time you got an error. It says, sorry, I could not fulfill your request. If you do not have proper logging and, like traces, the whole agentic system here is a black box to you. You won't know which one failed. You will obviously try to keep your user message generic. So it will take a lot of time to figure out which one is, not working as expected. But if you have proper logs, you can trace all of this and be like, okay, so my flight agent did work properly, but it was the hotel agent that actually failed here because of some other issue that is related to that particular API. And which is why the orchestrator was like, if I don't have hotels, there's no point in taking the flight. So I'll just send a generic response. And that will make you understand that, okay, this agent is the one that I have to fix, right? So we still need logs very much. And the next point is about testing, right? So for normally we write unit tests, integration tests, and then sometimes we even have E2 tests which run regularly when you push the code. What do you do for agents, right? So first thing, like I said earlier, each agent is built separately and it should be testable separately. Tomorrow, if you fix an agent and you want to check if it's working or not, you should be able to do that, right? So there should be some way you can manually test it, or you can run the tests associated with that agent. The second thing is actually doing a manual test. Until you don't have any testing pipeline in place or some evaluation ready for it, which I'll talk about in the next point, but you can just try to break the system, right? That will give you a lot of insights. Usually the way you build it is like you'll build the agent and it'll be a couple of, time before you actually have a proper testing system. Until then, doing manual testing and rigorous manual testing is enough. But once you are trying to change stuff a lot, having evaluation makes sense, because evaluation is essentially something like you will have a set of queries which are relevant to that agent. And these queries will be run against that agent every single time you make a change. Why do we need this? We need to ensure that the agents are still returning accurate responses, right? Tomorrow, if you make some big change and you're concerned if it will make sense, this is not as easy as running your unit tests and being like 100% passed, right? So what you do in evaluation is you run these set of standard queries every single time. And if you see a significant drop in your accuracy, you will know that, okay, something is wrong here. I messed up, I have to go and fix it. And then there's E2E. Till now, whatever I was talking about was for one specific agent. E2E is testing the whole workflow. So in the earlier example, that means we'll write queries where you're targeting the whole process, right? You'll write it saying that I want to plan a trip for this place. I want to book flights, I want to book hotels, a whole query. And you'll try to get all possible combinations of queries for that particular whole system and run it, right? These are the testing practices. And that's it. We're almost done with this Devday. And I would like to bring it back to the first, right? We started with what is the difference between a chatbot and agent. So now let us take an example of the travel agent and say that you can now decide what particular pattern or workflow works for your use case. And now you are equipped with information that will allow you to, like decide when to use MCP and not, and you can decide what MCPs do I want to use and search for it. If there are agents that are deployed elsewhere, you can then try using A2A. And then overall, now we're equipped with information that will help us build and maintain an agentic system, because now we know that tests, what are the types of testing that we can do, and also about, like what are the general practices that you can use. So that's it. Any questions or anything that we want to talk about? Get up for it.
How will general agents will scale?
Okay. You're saying you want to use like many agents?
Concurrency means at a time many people started using it, from 100 users to 10,000 users, suddenly it large cycle. How will agent generally handle that?
Okay, so I think one thing is parallelization, right? You can use whatever can be parallelized, you can definitely do it. This would not help in sequential workflows where you have everything, but some chunk of the work could be parallelized. You can try doing that. That would help.
And let's say it's a multi-agentic workflow, right? There are some basic entity extraction and stuff which need not even go to the orchestrator. You can do like a pre-processing itself. So let's say you have like so many requests, you can first filter out all the entity extraction and all what you can do without using an agent. You can like basically use an LLM call, or even without using it, normal Python scripts. So try to do as much as possible without involving these. And when you actually want to invoke it, by the time it reaches there, it will be like everything will be like processed, and the orchestrator can actually get the work done for you. So I think throughout the talk, what we're trying to emphasize is that since it is like buzzing everywhere, we're trying to like force fit. Like, let's say nobody is stopping us. For a calculator, you can write 4 agents, use orchestrator, and do addition subtraction. But do we need that? A small plus minus operation with if else works. Same case with the MCP. So another thing to keep in mind is MCP uses a lot of tokens. So as proper engineers, I think we should keep that in mind as well. Like not just hitting LLMs, and you can get any task done with 10 LLM calls. But is that what we want? We need to be judicious enough, right? Each MCP call that you make to an MCP server, it uses lots and lots of tokens. So if you're able to get the task done without using an MCP, do that. So, like as you said, nobody's stopping us from using all great tools for the simplest of problems. But then you'll have the concurrency issues. All issues come when we try to force fit it in places where it is absolutely unnecessary. So I think it all ties back to that.
One more question I have. I saw in terms of that multi-agent when you were explaining, one was orchestrator, which I have seen my customers and all do. But the second one, which you said, it's from multi-agent, where none of the agents have a fixed sort of rule and people can hand over or delegate the stuff. So where is that being used? I haven't seen it so far in any of the project. What's the use case where these kinds of agents, where you don't need an orchestrator or a supervisor, and where it will be useful?
Okay, so let's say I have tried this with Claude Code. So the thing that I tried one thing like, let's say I want to implement some code. So how do I implement it? I wanted a planning thing. Then I wanted to write code for it, review it, and then write tests. What, like if you're following TDD, then of course that comes first. So I tried it with orchestration approach. Like I had one orchestrator. It will be like, you do this, you write tests, you check. And I tried with Swarm approach as well. So in Cloud Code, you can add sub agents, right? So it allows you to do that. So what did was each agent will be aware of what the other agent is doing. And now let's say the planning agent will plan and it will hand over to the development agent. And the development agent, once it writes code, it will hand over to the critic or the code reviewer.
Without having any
yes. And there, if the code reviewer feels like the code is wrong, it will hand off to the development agent again. So that was something that I tried using. But I think mostly they go with orchestrator thing because we want some level of abstraction and something to actually delegate tasks. But for cases wherein you don't want any hierarchy and you don't want abstraction, like everything can know what each other is doing. For such simple use cases, we can like go with this one.
The whole purpose of the agent is to have it deterministic.
Yeah.
Right, and deterministic output only comes when orchestrator is there to take the accountability, and every agent has a fixed sort of in and out. Right, the moment you have a multi-agent in a very friendly environment of Swarm, the problem is you really do not have a crisp boundary of a agent where it starts and where it should stop, right? So
if it is like a long detailed process, then orchestrator definitely. And I think most of the use cases of agentic patterns, they go for this orchestrator or the supervisor approach. But if it is like a very simple use case and in which you actually don't want a supervision of sorts, and it is okay if there is no abstraction and everything can like work in parallel or talking to each other, we can go for this one approach. Like that exists, but is it used widely? No.
Because most of the cases need someone like an orchestrator
to hold accountable.
Yeah, sure.
What is an LLM? What is an LLM?
LLM. It's a large language model. So, are you saying anything? Okay. So, sorry? Yeah, so LLM is basically large language model. So if you're using something like ChatGPT, Gemini, something like that, so behind it there's an LLM, just like models like you would have heard GPT 4.1, 4.0, and Gemini 3. All of these are large language models, and they're trained on data which will make them understand the questions that we normally give easily, and they try to get an output based on the data that they have. But they're exceptionally good at handling stuff, generic stuff, and like conversations that we normally speak.
Yeah. Basically predict the next word or next token.
Yeah. How it's being done? So LLM is a model like learning and reading. What is that? What is that understanding?
I think you actually take a whole other talk.
You can consider LLM as your brain.
Yeah.
So your brain is typically the most complex machine that any human has created. And similarly, LLM is actually the most innovative thing. What LLM in simple words, if I put it right, what you do today is basically on today's circumstances and what you have learned yesterday.
But no, not the same. We don't predict. LLM is predicting machine.
We are also predicting. What you are doing today, I'll tell you the example. As a human psychological, what you are doing today is all because what you have done in the past.
Like
anything which is completely new to your mind, you will never be able to do it as you. That's a bet. We take it on human behavior versus LLM benchmarking. LLM is exactly your brain. And okay, I'll not take these people time, but I'll talk to you about it. That's how it actually works.
No, but LLM predict like actually feed some words. It's from 10 words, but we don't go like this.
You don't realize, but your mind is connected. You don't realize that the human, but brain connected.
Okay, I think we are running out of time and yeah, so
in short, I think we've covered most of this already, but if we would like to take away with one most important thing, it would be the third point, right? Use it where it is required, where you're using agents and MCP makes sense, A to A, everything. Use it in a use case where adding it adds some real value to the situation. Otherwise, maybe you can find something else, right? So that's it. We've got here are our LinkedIn profiles. Maybe like if you would want to scan it, you can go ahead and so any thoughts that you have on, like the session, like what can be improved, what went well, you can scan the feedback here. It would help us in, like the further dev days. So yeah.
Please take 2 minutes time to like.
Yeah, and I think before we get to this, I think we should give like a big shout out to Mahita and Swetha for taking time out of their busy schedule. Yes. They've come all the way from Chennai, by the way. So thank you so much, guys. I hope you guys had fun. So please fill out this form. It will drive us to conduct more such events. So yeah, just take 2 minutes. If anyone's not to gather on the table, that's right.
Next slide.
And these are like some forums in which like we keep posting about such events.